Good morning, children. In the chapter Periodic Classification of Elements, today we will learn trends in modern periodic table. Under that, I will teach you valence electrons and valency.
Teach you trends in periodic table. Trends, that means variation of various physical and chemical properties across the period and down to the group. That means when we move from left to right in the period or top to bottom in a group, how do the physical chemical properties change in the periodic table? Under the physical and chemical properties in standard 10, you have to learn valence electron, valency, atomic size, metallic and non-metallic properties, and finally oxide nature of elements. All these properties you have to learn in standard 10. Let us discuss in detail one by one all these properties. The first property, that is valence electrons across the period, that means on moving from left to right in a period, for which I have taken third period, elements of third period. Let us start with first property, that is valence electrons. How do the valence electrons change on moving from left to right in a period? For third period, the elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Electronic configuration. For 11, atomic number 281, magnesium atomic number 12, 282, aluminum with 13 atomic number 283, silicon 284, 285 for phosphorus, 286 for sulfur, 287 for chlorine and 288 for argon. So this is the electronic configuration of third period elements. Already you have learned about the valence electrons. The electrons present in the outermost shell of an element, atom of an element is called its valence electron. So valence electron of sodium is 1. Magnesium, the electron present in outermost shell is 2. So the valence electron of magnesium 2, aluminum 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7 and argon 8. That means when we move from left to right in a period, on moving from left to right in a period, the valence electrons increases from 1 to 8. The valence electron increases from 1 to 8. That is across the period. Now let me explain you how do the valence electron change from top to bottom in group. Let us take the example of second group elements. The elements of second group: beryllium, magnesium, calcium. As we have to learn up to 20 atomic number, I can take only these three. Atomic number of beryllium is 4, magnesium 12, calcium 20. Write the electronic configuration of all these three elements. Beryllium 2, 2, magnesium 2, 8, 2, calcium 2, 8, 8, 2. So if you see the valence electron of second group elements, all they have 2 electrons in their valence shell. So what conclusion can you draw by this? Valence electron in a group remain same. All the elements in a particular group have same valence electron. No change in the valence electron from top to bottom in a group. Property that is valency. How do the valency changes in a group or in a period? So before explaining about the relation of valencies in a group and in a period, let us discuss what is valency. How can you define a valency? Yes, valency, it is the combining capacity of an atom of an element. Okay, so valency, in other words, we can also define as the number of electrons lost or gained by an atom of an element in a chemical reaction, or number of electrons shared by an atom of an element is also known as its valency. In junior class already you have learned how do the valence electron is related with its valency. Let us recall that one. So valence electrons, if the valence electron is 1 to 4, the valency is equal to its valence electron. Okay, but if the valence electron is more than 4, then valency is 8 minus valence electron. Now, let us discuss the variation of valency in period. Again, for which I have taken third period elements: sodium, magnesium, aluminium, silicon, phosphorus. Just now you have learned about the valence electron. Valence electron of sodium is 1, magnesium 2, aluminium 3, silicon 4, phosphorus 5, sulfur 6, fluorine 7, argon 8. So just now what I said, either we can go for in terms of loss or gain of the electron by an atom, or you can go for in terms of the valence electron relationship of valency and its valence electron. Here, as sodium atom has one electron, it is easy for sodium atom to lose this one valence electron. So the valency of sodium is 1. Magnesium can lose these 2 electrons to form Mg2 plus ion. So the valency of magnesium is here 2. Aluminium valency 3 because it can lose these 3 electrons. Whereas silicon, it can share 4 of its electron with other atom, hence the valency is 4. Or you can see here 1, 2, 3, 4. They are having valence electron less than 4 and hence their valency is 1, 2, 3, 4 respectively. Now come to phosphorus. As the valence electron of phosphorus is 5, it requires 3 more electrons to complete its octet. The atom of an element can lose or gain the electron in order to get the nearest inert gas electronic configuration. So here phosphorus, by gaining 3 electrons, it will form P3 minus ion, phosphide ion, and hence we can see its valency is 3. It can gain 3 electrons and hence the valency of phosphorus is 3. Next come to sulfur. As it has a 6 valence electron, either you can say 8 minus 6 is equal to 2, or in terms of gaining of electron, as sulfur it has 6 electrons, it requires 2 more electrons to complete its octet and hence the valency of sulfur is 2. Chlorine 1, 8 minus 7, 1. Argon, its valence electron is 8, it is already complete octet, has complete octet, so its valency is 0, or we can say 8 minus 8 0. So if you see the valency across the period on moving from left to right period, the valency first increases from 1 to 4, then decrease to 0. Okay, 1 to 4, it increases from 1 to 4, then it decreases from 4 to 0. This is across the period. Valencies of a group. Children, all the atoms of an element in a particular group have same valence electrons and hence they have same valency. Valencies of all the elements of a particular group elements are same because they have same valence electrons. Let us discuss this through an example. Group number 1 and group 2 elements. In group 1, the elements are lithium, sodium, potassium, group 2, beryllium, magnesium, calcium. If you write the electronic configuration, lithium 2,1, sodium 2,8,1, potassium 2,8,8,1. That means all the elements of group 1 have same valence electrons, and as they have same valence electrons, they have same valences. Likewise, in group 2, beryllium 2,2, magnesium 2,8,2, calcium 2,8,8,2. So that all the elements of group 2, again you can see same valency. So the valency for group 2 is 2 and valency for group 1 element, all the elements of group 1, they have valency 1. So for a particular group, elements have same valency.